It might well be that the monster black holes in the middle of galaxies actually helped the galaxies form and therefore helped life come on the scene.
But physicists have always known that relativity is an incomplete theory of nature. Although it beautifully describes how gravity influences the motions of planets, stars, and galaxies, it can never describe the world at the smallest possible scales. The realm of atoms and the tiny particles that form them. To do that, they use a separate theory, a theory called quantum mechanics.
You might wonder why we'd want to apply quantum mechanics to something as large as a massive black hole, when quantum mechanics deals with the very small. And that's because ultimately, at the heart of a large black hole is a singularity.
It seems quite likely that in order to really understand what goes on inside a black hole, we will need quantum mechanics. That the final story of how a black hole works and what happens at the singularity can only be understood when quantum mechanics is included.
All of our notions about how things behave change. For example, an object has a known location, I'm here, you're there, but at a quantum mechanical scale, objects can be in many different places at the same time, literally.
Yet strange as quantum mechanics is, theorists believe the world it describes is the true nature of reality.
Quantum mechanics is so weird it may sound like science fiction, but it's not science fiction, it's science fact.
So there's no question that there's some great truth in quantum mechanics.
But there's one thing quantum mechanics can't describe: gravity. And it's not normally a problem, because atoms are so light, the effect of gravity is irrelevant.
Most of the time, quantum mechanics and gravity leave each other in peace. But there's one arena in which they're both important. And that arena is when things are both very small and the force of gravity is very large. And that's what happens inside a black hole.
When physicists tried to combine the two theories, they encountered a familiar problem.
I insert this into the probability that gravity will move from one point to another point. When I actually do this calculation, I get yet another integral. And when you do this integral, you get something which makes no sense whatsoever. An infinity. Total nonsense. In fact, you get an infinite sequence of infinities, infinitely worse than the divergences of Einstein's original theory. This is a nightmare beyond comprehension.
I think the most embarrassing problem we have in theoretical physics is that we have these two different theories which won't talk to each other.
The equations no longer make any sense. And nobody knows exactly what we're supposed to do about that.
Something is fundamentally wrong. Nature is smarter than we are.
If we want to understand the universe, we must understand how quantum mechanics and gravity can live together. And so that's our challenge.
The trouble is, although we know black holes are everywhere, we've never seen a single one directly.
Have you ever seen a black hole?
No.
Have you ever seen a black hole?
No.
No one has ever seen a black hole directly.
Right there. But I can't ever be 100% sure about that.
Is that because you can't see it?